Hello everyone. Hello my students. This is the unit number 1 in artificial intelligence and robotics. Now I'm going to talk about the image processing and analysis. This is the short video. I'm going to discuss this particular topic alone. Let us move to the topic. The image processing and analysis, it is a part of machine vision system. So sensing and digitizing, this is already we discussed. Now we need to talk about image processing and analysis. This various technique and how we are doing the detailed discussion. We are going to have it at unit number 3, second half. Now this video I am going to give a brief presentation about image processing and analysis. Image processing and analysis. Here previously we got the images we are got for image capturing, digitizing, what is called sensoring and digitizing. The sensoring and digitizing, we are taking as input, and we are doing processing and doing analysis. Different techniques of image processing and analysis, the image data in the machine vision system. Actually, our subject, we are talking about a robot have a machine vision system, and it will be used for several applications. The one best example is the doing work, inspection work at the industry. One component dimension, it will be captured. It is already stored. That the standard dimension, it is matched with the original component dimension, and if it is matches, it will be passed for inspection. If it is not matched, then that will be rejected. This is the original application. So here, for doing image processing and analyzing, we have two topics. That means two technique. One is segmentation and feature extraction. Segmentation subdivided into two different techniques. One is thresholding and edge detection. Coming to thresholding, thresholding means we are converting into the binary data, binary value. Binary mean, bi means two. Binary means you have two values. Before going to the text, so first we need to see it is segmentation. It is intended to define the separate region of interest within the image. So there are several regions are available. We have to we have to separate define the separate region of our interest within the image. Here, set by segmentation, we have two techniques. One is thresholding. Thresholding means conversion of each pixel intensity into the binary level. Already you have an image. That image we are converting into the binary value. Already I said binary means two. Here, binary value means either black or white. If you get a binary value is 0, it is called black. If it is a white, it is called 1. So 0, 1, this is the binary value. Okay. Now there is a threshold value of intensity we have. Each and every picture having threshold value of intensity. If the value of pixel of the image, so the value of the pixel of the image is less than the threshold value, it is called 0. Suppose the pixel of the image is greater than the threshold value, it is called white. If it is less means it is called black in color. 0, it will be the value, binary value is 0. The color code is black, and otherwise if it is greater than, then it is called white. So you look at the example here, Mona Lisa picture is there, before and after thresholding. So here, except the Mona Lisa face, body, the background, it will be at a white background. Remaining everything, it is at a black background. Coming to edge detection. So edge detection means this is what I already said. This application, the template matching. Template matching, it is an inspection part. Here, edge detection means only the edge of the images it will be taken. Let us go to the text. Determine the location of boundaries between an object and its surrounding in an image. This is accomplished by identifying the contrast in the light intensity that exists between the adjacent pixel at the border of the object. So here again, we don't want the whole information in the picture. Just we want the edge detection. Edge of the Mona Lisa picture is sufficient. We need not look at the background, everything. It is not required. So therefore, if you are applying for edge detection, so here they are only the body, right? The edge of the body. it will be captured, remaining it kept ideal. This is a typical technique, edge detection. The real application is the inspection. So that once edge detection, they will make a standard dimension. That dimension again, what they will do, they will match with the original component, inspection purpose. If it is exactly matched, it is passed for inspection. If it is not matched, rejected for inspection. This is the real time example to understand what is edge detection. Coming to the future extraction, this is another technique in the image processing and analysis. The image processing here, what kind of features they are extracting means like area, length, width, diameter, perimeter from the image. So various dimensions. The best example to understand this is feature extraction. There is an object is there like leaf. You can look at the picture. There is a leaf is there. They are drawing the grid line, then they are drawing the grid line over the leaf diagram. Then they will doing. Otherwise, what happened? The proportion of the leaf, it will not be unique. So one body is there. What the dimensional proportion is important. For example, you are drawing a picture, human picture. Suppose without grid lines, without concentrating the proportion of the body, simply if you are drawing, then what happened? Sometimes the body head, it will occupy 50% of the whole body. Originally, it will not happen, right? Therefore, in future extraction, they are drawing grid lines like this, and there they are capturing the area, length, width, diameter, perimeter, everything. Okay, therefore, the replication of this diagram, it is very easy. And one more best example to understand future extraction is I think you know 3D printing. The 3D printing, the process is we will model the component by using CATIA or SolidWorks software. That original modeled picture into original component printing, we will introduce a slicing software. That slicing software, what happened? The modeled component, it will be sliced into n number of layers, and it will print layer by layer. Right. Similarly, this is a same example. Here, what happened? Entire image is divided by the grid line. So, grid by grid, if you print, finally you will get the overall picture. Right. With this, I conclude the image processing and analysis.